Hey folks, hopefully you are here to hear me talk about managing asynchronous APIs. And by what do I mean by that? Well, I mean that we need to talk a little bit about the idea of if we have asynchronous APIs, and I'll explain what I mean by that in a minute, how do we manage them? I talk a lot at various conferences about building them. Once you've got one, how are you going to own it? Okay, who am I? So my name is Ian Cooper. Some of you may know me from talks about test-driven development or event-driven architecture. I've been doing this a while. I used to have hair on my head, and I used to have a beard that had some dark color in it. But the point I really try and draw out is I'm just like you. I'm just another developer. I'm not particularly smarter because I happen to be on this stage. I'm just sharing experience. We are all of us capable of doing all of the stuff that I'm talking about today. So please don't feel it's kind of expert to learner here. I work on an open source project. If you are a .NET developer particularly, we provide a messaging framework. We cover the functionality of something like Mediator, but we then also let you work out of process and use a messaging transport. We've got a V9 release coming out in a couple of weeks with better support for outboxes and things like Entity Framework Core. If you're a Python developer, we have a Python version, but it's languishing a bit and needs some love. Here's the agenda. That's probably a bit wrong. I'm knocking off a deck over there because I've got some AV issues. But we'll talk about endpoints. What are they? What do I mean by endpoints? We'll talk about how we discover endpoints. And then we'll talk about, there's more than just AsyncAPI, some things that help us with the process of endpoint discovery. All right. So first of all, I think I should probably define what I mean by an asynchronous API, or what are we talking about? So a synchronous conversation is one where both parties are present. And it fails if that's not true. If you can't pick up the phone call and answer, that synchronous conversation will fail. It requires both parties to be present when it happens. Typical example of phone call, right? I pick up the phone and I phone you, that conversation is synchronous. gRPC, HTTP, those kind of protocols tend to be synchronous, right? I call you, the server needs to be online and present. An asynchronous conversation is one where both parties don't need to be present. What happens is that you deliver to some kind of mailbox. A message queue is really just a mailbox. And the work sits there until the person effectively who is the receiver decides they want to pick it up and process it. And that obviously has lots of useful properties. The receiver doesn't have to actually be up when you send the message. And the receiver can throttle, they can decide when and at what rate they want to consume messages. Snail mail is the classic example, but we all use messaging apps today, like WhatsApp, Signal, whatever your preference is. The only person that phones me is my mum. Everybody else just sends me a WhatsApp message or a Signal message or a text. And they do that because it's really inconvenient to call me and I'm not there, that you can't get anything done, right? If you send me a message, I can just pick it up and deal with it when I'm ready. And my mum likes to hear my voice, right? But everybody else just sends me a message. And the same is really true of our software today. It is a lot more robust to send somebody a message and let them put it in an outbox, let them get to it when they can, let them process it when they have availability to do so, than it is to demand that the other party is up and running when you send them a message. And that's why we try and push, particularly in Microservices world, a shift to asynchronous APIs a lot. This talk is not about why you should use asynchronous APIs, however. There are lots of other talks I give and others give about that. But it's more about, once you have them, how do you look after them? How do you own them? All right, one of the words I'm going to use here is endpoint. What do I mean by an endpoint? I'm actually going to use a definition that comes from Microsoft and from the days of Windows Communication Foundation. I think it's a pretty good definition. It's places where messages are sent or received. That's what we mean by the endpoint. Your application has an endpoint. You may be using it to send messages. You may be using it to receive messages. You may be using it to do both in an app. Quite often our app sends and receives messages, right? And by that, really, as an endpoint, we don't necessarily have to mean an asynchronous protocol. It could well be a synchronous protocol. And generally, when we think about an endpoint, we want to know a number of things. We want to know what's the message that I'm going to send or receive on this endpoint. If I am the receiver, I might want to know where it's coming from. If I'm the sender, I might want to know where it's going to. And I likely want to know how I send it. And by how, we mean things like, am I sending this over HTTP? Am I sending this basically via Kafka? Am I sending this via AMQP? If I have those pieces of information, I know enough to communicate. Let's take a little detour for a moment into domain-driven design as an idea. Okay. So in domain-driven design, we have basically a domain, right? Currently, I work for Just Eat Takeaway, so I work in the domain of delivering takeaway food to your doorstep. And within that domain, we may identify what we call subdomains, little bits of that puzzle, right? So I tend to focus subdomains on business processes. So it might be checkout order, fulfill order, place order, provide menu, right? Those kind of business processes. And they're subdomains, so it's easier for us to reason about and think about those. Right? And what we tend to do as software engineers or architects is we model that subdomain. We say, let's model this particular subdomain and let's write some code to implement that subdomain. Let's create some schemas to implement that subdomain. And let's have a language we use within that subdomain and the product team to talk about the concepts. Let's create a shared understanding of that subdomain. Okay. Now, sometimes we don't get the world right and our bounded contexts don't align very well with our subdomains. That's generally a historical situation where the subdomains change, our view of the subdomains change. We've got legacy bounded contexts and mapping gets more complicated. But let's assume we have a better world where our subdomains and our bounded contexts align quite well for the moment. And typically, our microservices represent the subdomains. Our microservices are therefore bounded contexts. Don't get that wrong, by the way. It's not really about microservices being bounded contexts. When we talk about what microservices target, it's really about microservices targeting subdomains and thereby being a bounded context. All right. We name a bounded context, right? So I've got two here, restaurant management. In other words, that talks about getting restaurants onto our platform. And restaurant availability. Is the restaurant open? Is the restaurant serving food? How long will it take the restaurant to serve food? All right. Has the restaurant had some terrible kitchen disaster and needs to close for half an hour? Okay. And you'll notice we may have shared concepts. Restaurant management is going to tell restaurant availability about restaurants and their opening hours, etc. And the question really is how these two begin to communicate. How are we going to communicate between restaurant management and restaurant availability about life and things, right? And particularly, how are we going to communicate about shared concepts like restaurant? Because we have different models. I'm modeling restaurant availability, I'm modeling restaurant management. They're two different teams, two different sets of code, two different schemas, probably two different product owners, and we think about things differently. In restaurant availability, I really care a lot about hours. I care about the hard problems about scheduling during time zone changes and things like that. In restaurant management, I care about getting people on board, signing a contract, who's the contact detail, where are they located, right? So we have to kind of come up with some agreement about information that we'll share. And we tend to think about the idea of there being an upstream and a downstream team. And what do we mean by that? Well, generally in a relationship, somebody is producing information and somebody is consuming it. And the producer is kind of upstream and the consumer is downstream. And the reason we talk about that particular metaphor is if you are upstream of somebody, like you're a city, and you pollute the water, the poor old people downstream have to deal with your behavior. So the problem is there's no real constraint on the upstream team on what they do, but the downstream team continuously suffer as a result. So what we try and do is say, well, we should have a customer-supplier relationship. People upstream should be suppliers. People downstream should be their customers. And the supplier should try to look after and take care of their customers. They shouldn't abuse their privilege of being upstream. They should say, hey, what quality would you like for your water? Should we color it today? I don't know, whatever. All right. So the bad world is called conformance. And that says the upstream team just says, you know what? I've got a data structure about restaurants. I'm just going to publish that. From our point of view, talking about asynchronous conversations, they're publishing an event. But it could be, this is generally applicable to all kind of interactions between two services. If I just publish it, I publish my internal structure. Downstream teams start consuming it. They conform to the structure basically that the upstream team uses. One day the upstream team says, oh, you know, I think we should change the way that ID works. We switched from using SQL Server to Dynamo, and it turns out, you know, that old incrementing identity value we use is not going to work for us. Let's have a GUID. Someone goes, yeah, let's make that change. A few days later, upstream team changes their event model. Yeah, hey! Downstream team starts saying, everything's broken, we don't understand why, what happened. Right? The downstream team is dependent on the schema that the upstream team uses internally. They'll just break. Okay. So the problem with this conformance model is it's really antithetical to one of the key properties of microservices, which is independent deployability. The restaurant management team ought to be able to change their internal code base. They ought to be able to change the schema in their data stores, to change their data store, and it shouldn't have an effect on restaurant availability. They should be able to just keep working along, just as they did yesterday, getting useful restaurant information. So the first rule really is we don't want to publish our internal representations straight onto the wire, because the problem is we will break our consumers. Now, what the downstream team could do is introduce an anti-corruption layer. They say, all right, we'll write something defensive. It'll listen to whatever we get from upstream, and it will convert it into the representation that we want to see and we want to depend upon. So we'll take whatever version of restaurant they're giving us and we'll convert it into something that looks like the restaurant we expect. Oh, they've changed the ID value? Fine. We'll cope on our side. We'll do something in our anti-corruption layer to put in an ID number that basically is we can understand. And that works, but it's not very effective, right? Because every downstream team that listens to restaurant management is now writing an anti-corruption layer to protect themselves against the bad behavior of the folks upstream. So it's a great defensive measure if we don't control restaurant management. If they're outside of our purview, they're a third party that we don't trust very much. But if they're part of our organization, they can behave better. So what we do is we say, they're a supplier. We should have a contract with them. And the contract agrees what they will supply to us. And they will agree what the model of a restaurant is that they will give us. And they will agree that that model won't just change every 5 minutes, but they'll try and produce changes that are backwards compatible. We will agree probably to be what we call a tolerant reader. That means If somebody adds a field we don't depend on, that's okay, we can ignore that. Maybe we'll agree with the upstream team that there are certain defaults we can use sensibly, and in the event that information is not there, we'll just swap in one of our defaults. And that allows the upstream team to make some changes. They can add new fields for new customers, right? We'll just ignore those. But otherwise, we try and remain consistent. And if someone's going to create a breaking change, like changing an identifier from an integer to a string, we'll have a discussion about how best to manage that. We'll have to version the contract. We'll have to come up with some approach like providing both identifiers for a period of time until we can all move over. But it's a contract and it's a process of negotiation and agreement between two parties. And the thing is, it frees the upstream team. Restaurant management can now change their internals as much as they like without fear that they're going to break everyone downstream, because they're continuing to honor the contract. And we talk about this as necessary coupling. We all, as software engineers and architects, I'm sure, recognize that what we want is high cohesion and low coupling, right? Particularly if we have kind of microservices, we recognize the goal is low coupling. I want to release my microservice without talking to you about that release. So we all recognize, we don't want too much coupling, but some coupling is necessary, right? If I don't couple at all, well, no one's using my service. It's not doing anything, right? No one can talk to me, and I'm in perfect isolation. I'm probably not offering a lot of value. So folks want to talk to me. So there's a certain amount of necessary coupling. You have to talk to me to get my job done. We're going to have to agree to couple. So we want to manage that coupling. And we manage that coupling by thinking about it as a contract. We've taken this decision to couple to you. Hey, we'll do that by a contract. So we won't change that stuff because we know that people could couple to it. And therefore, we want to manage their ability to change, so we won't keep forcing changes on them. So we can talk about basically creating some kind of habitable relationship with both the supplier and the consumer. We have a contract, and that contract allows us both to survive the fact that we've coupled together. Anyone familiar with promise theory can understand that essentially what's happening is that we can think of the microservice as kind of a super agent. It's able to make promises about its own behavior, and it can say, I can make promises to you, contracts, about what I will expose in the future. And an endpoint is really just this contract that I am making to other services about what I'm going to provide. And really it consists of a contract, a binding, and an address. Sometimes in WCF, we used to talk about the ABCs of a contract. Remember we said basically where messages should be sent, how they should be sent, and what they look like. What they look like is the contract, where they should be sent is the address, and the binding is how they should be sent. Okay. Oh, I thought I had another little slide there. Never mind. Okay. I will move on a little bit. I may have a need to just change an AV issue in a second with the graph. In a second, I will, if I get to it, I will. You may not have the current version. So, all right. One of the questions then I might want to ask is, how do I discover these endpoints? Someone documents their contract, and I, as a service, say, I need to know about restaurants. Where am I going to find that information? Now, lots of orgs, typical problem space is, I go on Slack and I ask everybody, I say, anyone know who creates restaurants? Because I can't find where it is and I need a restaurant for my service. Or the other thing typically that happens in orgs is someone goes, okay, I'll just search our enterprise GitHub and see if I can find messages entitled restaurants. That'll be what I need to do to solve this problem. Okay. And as you can imagine, that's not really a perfect world, right? If I am the provider of a message, I'm going to have a similar problem. My problem is going to be I don't know who consumes my messages. I know that I produced this message which tells me that the restaurant hours have changed, but who consumes it? It might be nice to know that sometimes. Now, I don't want to couple to them. That's certainly a bad thing, right? But what I do want to do is sometimes say, well, hey, have I got some consumers of this message? That's a little bit of a problem, right? Because where am I going to find it? Again, the problem seems to come down to this usually in most organizations. What I'm going to do is go onto Slack and ask a question and say, hey, everybody, can you tell me who consumes my message? Can you tell me if you use it? I mean, that's not really that useful, right? So if the only way we are documenting our messages is to document them by essentially putting the information in our GitHub repo in a markdown file where we kind of say, oh, here's our message structure, or, oh, here basically is the code that represents the endpoint, it's very difficult for us to communicate with other people. Generally, people need to know a number of things. They want to know what is the content type of our message, and probably they also want to know what the encoding is as well. Okay. They may want to know what's the schema of the message? What does it look like? What's the shape of it? What are its fields? Okay. We probably also want to know what metadata has been supplied. By metadata, we mean the headers. So we may have header information which helps us process the message. If we haven't defined that, it's going to be really hard for us to basically work with those messages. We may want to know what protocol we need to use to talk about it. Do you talk Kafka? Do you talk SNS? Do you talk AMQP? How can I talk to you? All these pieces of information are something we're going to have to discover in order to use your service. So we can think about our endpoint, which we defined as basically these ABCs, right? I need to know the contract, I need to know the binding, I need to know the address. And we can say basically, well, we're going to need to document our message, the thing that we send or receive. We're going to need to document probably both the headers and the payload of that message. What headers do you have? What do they contain? Do you have tracing information? What is the content type? What is the content encoding? Do you have a message ID? Do you have some kind of correlation ID? Do you tell us where you reply to on reply messages? We're going to need to understand the channel. Where does this message travel? Channels in messaging quite often sort of a pipe between the producer and consumer over which stuff flows in a single direction. And they're quite often given a logical address. And in most messaging platforms, we think about a topic or a routing key. So AMQP 091 Rabbit is a routing key. In Kafka or SNS, it's a topic, right? Where am I sending this? Where can you subscribe to it? How could you possibly listen to the message? And what's the binding, right? If I'm going to listen to this message on this channel and pull it off, what do I need to do? Do I use Kafka? Do I use Google PubSub? Right, so you need to document all those things. All right.
If you just give me a second, I'm going to get, just upload a later version of this presentation because so the AV is not working between the laptop, so he's got my deck over there. And I just need to get him to start downloading a new version. If you give me a second. I apologize for interruption. Oh, okay. All right, just give me 2 seconds while I get him to do the update, and then I will have, I'm just missing a couple of slides that I want you to see. It will take me 2 seconds to get this guy to do it. Sorry, I think I got a slightly older version. Can you just get to that GitHub AsyncAPI? If you just do search for GitHub AsyncAPI. Just search GitHub AsyncAPI and I can find it for you. Yeah, and I should have a newer version. I just uploaded it. The timestamp changed. It's just the managing async APIs. M for managing. Yep. Should be a P PowerPoint. Yep. Should just committed it 1 minute ago. Yeah, last date 1 minute ago. Just download it. You click the down button to the download because it's a binary. Yeah, so it needs to do that. And then you just play that one, and that'll be the correct version. Thank you. All right. It's amazing, isn't it, quite how we've reached 2021, but we still don't really have. But AV can still be a trial for us all. All right. Hopefully, you get a nice recap as it speeds through. So you can all go, wow, fantastic. Ian remembered to put a recap into his talk so that when I was confused, I could see all the slides whiz past. You regret animation when you have to whiz through everything at high speed, don't you? You didn't see that slide, but don't worry. It's just basically saying that we need to document asynchronous APIs as well as synchronous APIs. And that's why I knew I had a slightly older version of the deck. All right. Here we go. So one of the major games in town is AsyncAPI. AsyncAPI represents basically an emerging standard for documenting your endpoints. It's recently become part of the Linux Foundation, and it has a very open governance model. There are some key kind of project owners, but then effectively it has very open contribution model. It has a community on Slack. You can all go and get involved and help define it. And they're a lovely, lovely bunch. And they have kind of regular Zoom meetings you can kind of join in, and they're all over the world. So, lovely bunch. And what they give you is a specification for defining an API. And then they give you tools, which we'll look at a little bit during the session, which say, well, given you've defined this API, JSON and YAML, I can parse that, and I can run a tool chain for you. And there are emerging community-based tools around it as well. So the way AsyncAPI works, it says, well, there's a producer and a consumer. And there are roles my app could take. Because my app, I might send some messages, and I might listen to some messages. So I can be in both a producer and a consumer role. And I send a message over a channel. It's a word we heard before, right? So a channel is this logical construction given a name where I'm going to send a message. Has to be addressable, because essentially I must be able to send to it, and that address is really a name. And channels are usually hosted on a server. Now, in AsyncAPI 2, generally the server abstraction, if we're using messaging via a broker, is a little bit redundant. We'll talk about that in a second. But if you're using something like WebSockets, the server is a role one of you will be playing, like the producer. If you're producing messages, you'll effectively be the server. We'll come back to the server issue a little bit later. Okay. We send a message, and it has a payload and a header. And there's a protocol, or called a binding, which tells us how are we going to use a specific protocol, like Kafka or an SNS, to send this. How are we going to configure that to work? So an AsyncAPI specification has a top-level object called an AsyncAPI object. Some of you who've done OpenAPI may find this model familiar, and that's because OpenAPI was an inspiration to the AsyncAPI team when they began working. They looked at the way OpenAPI was able to document HTTP endpoints and said, wouldn't it be great if we had something similar for doing messaging, particularly in their case, I think, WebSockets. Info object is a top-level object which says, what is this specification about? Right, it's metadata about the specification. Who should I talk to? Which team in the organization owns this endpoint? The server's object says, okay, what hosts effectively this endpoint? And the channels object says, what are the channels? What are the things over which messages are flowing? And within the channels object, because you may have more than one channel, because you both send and receive, you have operations saying, I'm going to send something or I'm going to receive something. And they have under the operation a message saying what I send or receive. There's a component section, and what that lets us do is take common repeated bits of definition like message schemas, put them in a central place, and tags, so I can effectively tag my spec for purposes of searching, etc. Okay. So the top level object really has just one property, an ID, which is the identifier of the app the specification is for. You write a specification for a given app, so you would write one for a microservice. The info object has some useful information. I've just documented for fun and giggles one of our sample applications in the Brighter project. And it has stuff like saying, well, where do you go to find help about this? Where would you go for support? Don't email that email. It doesn't exist. And a license information, which is a bit strange. If it's internal, you just put something like local. It's a required field, which is a bit weird. A description effectively of what this specification represents, right? So someone reading this can go, oh, okay, this is the spec for that app. A version number, in other words, essentially which version of the specification is this, so I can effectively version and iterate my specifications if I have to move forward. It's a contract, it should have a version. And tags. The server's object, you can have multiple servers, so you can do production, staging, QA. I'm just defining a local one here. And the protocol, how do I talk to the server that effectively is working here? And then perhaps most importantly, the channel. So the channel is what I'm communicating over. So I'm defining a channel called greeting. In, say, Kafka, this would be a topic. Right. And I describe an operation on it, subscribe. I'll come back to subscribe in just a second. The operation ID is really used for code gen, saying what would I call this particular operation if I code gen something around it. And then I say, what's the summary of what I'm doing and what's the description of what I'm doing, right? And then what's the message that goes over the channel with this operation? Notice that although all the description says I am sending something, the operation is subscribe. Why is that? Well, because of the history of AsyncAPI, what it's defining is what operations do I expose to you? And if I am a publisher, I expose the subscribe operation. You can subscribe to my messages. If I am a consumer, I expose the publish operation. You can publish to me. That makes sense in the kind of WebSockets world it came from. It doesn't make so much sense in a pub/sub world, and we'll come back to that again at the end, as I say. A ref is a way of saying, in the spec, you saw one on the previous page, see a ref for the message, right? A ref says, hey, I'm not going to define that here, it's somewhere else in the spec because it's shared. Typically a message might be used in multiple places, and so here I'm doing a ref where it just says, actually you can find it in the same document in the component section, and here I'm saying, actually it's in this other file in the component section. The other file one's quite useful because, as you can imagine, I've got two apps. One is sending a message, the other is receiving a message. I can have a shared definition file with a message in it and share it between the two apps. That's what a component section looks like. You can see that effectively I have a schema for a message, and it has internally refs to describe the payload. The traits are a way of providing common header reuse, and a schema for the message. Out of the box, AsyncAPI supports JSON schema to describe its messages, but it is open to any format. And we'll discuss some other formats in a second that you could use. Right. So it isn't constrained to saying you must describe your messages in JSON schema. You just need to tell it, you just need to document what you're describing your message format in. So the structure, how well does that map to the requirement we gave earlier around basically an endpoint consisting of a message with a payload and a header, a channel, what do we send it over, and a binding? Well, we've got some information about the endpoint, right? And really, though, a bit strangely, when we talk about basically channels and operations, the things that the endpoint makes available, they're actually a bit closer to a kind of our general endpoint description. We certainly, in the operation, have a message, which describes the message with a payload and a header. But we have also this weird servers object for hosting the channel. And the binding information, which describes how a given protocol supports stuff. So what happens is you add binding information, say, to operation, etc., to describe how your protocol supports that. It's spread throughout. So there's currently discussion in the AsyncAPI community about a v3. And v3, the intent is really to support pub/sub a bit better, make it a bit more intuitive. So what you can see is the operations have been taken out from under channels and made a top-level item. So you're saying my app sends some stuff and my app receives some stuff. That's the action you can see there. And it does that over a channel, which I've defined elsewhere. And you can say in its bindings, hey, am I actually a server, or do I just use a piece of middleware to do that? So there'd be a better support for pub/sub in v3. Some of the details there are still under kind of development. And it's a good time to go try and influence that spec if you're interested in that kind of thing. But better support for pub/sub is coming. It's very usable today. We use it to define producers and consumers. It's just a little bit, you have to explain counterintuitive stuff like why is it publish versus subscribe at this point, right? I've taken that feedback, and the next iteration I think should be very solid. 2 is definitely kind of early adopters, people giving feedback. 3 I think is probably where early majority will come in. There is tooling. They provide basically a studio. You can write your YAML or your JSON, and it will display something that looks like HTML. We'll come back to that. What documentation? You can put it in Visual Studio Code if you like, and it will basically do the same thing for you. Backstage and other similar libs are starting to support AsyncAPI. What's Backstage is for? Backstage, if you don't know, it comes out of Spotify, and it's really a portal for us to put developer documentation. So if I want to discover what services do we have and what events do they expose, I can use something like Backstage to hold my AsyncAPI documentation so developers can discover what endpoints look like. There's also tooling emerging from the community. This one, I don't think is perfect at what it does, but you can see that it's possible once you have definitions for your endpoints to begin to graphing out the flow. And visibility of event-based, of asynchronous APIs is a real problem, right? How do I know what's actually going on under the hood? This gives you a kind of static viewpoint. It lets you say, at a design level, what would the flow of messages in my system look like? We'll talk about operational understanding of that in a bit. Okay, so we said it supports JSON schema, it also supports other formats. What are the ways of describing our actual message? One of the big emerging standards at the minute is CloudEvents. So CloudEvents is across a number of vendors, really across the people that compete with AWS, because AWS are not part of the CloudEvents standard. But it's an interesting and quite useful tool to use. CloudEvents is focused on events. Let's just define commands and events for a second. All right. A command is an instruction. My example is usually make me a cup of tea. An event is basically a fact. I am thirsty. Okay. Events tend to be one way. I broadcast it. I don't know if anyone's ever going to respond to it. I just broadcast that fact. Commands often imply a reply. Please make me a cup of tea. I'm expecting to get a cup of tea. Commands, typically I know the recipient. I'm addressing somebody and giving them an instruction. Events don't have any knowledge, basically, of who actually subscribes it. Maybe nobody listening, for all you care. One recipient or zero to many subscribers. CloudEvents has focused itself on events, hence the name. So they've deliberately restricted the scope of their work, and as such, the specification has nothing really about routing, right? It considers that a protocol-specific concern, and it also considers that events may flow and may change who they're between at any one time. So things like reply to or to, these are not things that you will find. The topic, you won't find those in CloudEvents. Doesn't mean you can't use them, but it means it's not covered by the standard. Okay. Generally, CloudEvents is basically concerned with the metadata more than anything else. All right. So it says, my event consists of metadata and a payload, and my metadata consists of required and optional attributes. I have an identifier for basically my message and a source message, right? So this application sent it and it had this ID. Between the two of those, it's unique. IDs could repeat between people sending a message, but for any given producer, the ID should be unique. Spec version, so which version of CloudEvents are you basically defining it with? And a type. So basically, it's the kind of name in the message, like my greetings message, and generally the version information goes here, like greeting v1, greeting v2, if you have greeting information. Optional attributes, you don't require them. It makes assumptions otherwise. What is the content type? What is the MIME type, basically, of this message? Application JSON, application Avro, right? What is the data schema? What does the payload look like? Notice that CloudEvents is not defining payloads. So CloudEvents is perfectly usable with AsyncAPI. AsyncAPI, you could have a JSON description of the schema of your message, and you can treat CloudEvents as a set of traits that define the headers that your message is going to use. Subject qualifies the ID and source information with more detail if necessary, and a timestamp. When did the message get sent? All right. There are two types of binding to specific protocols like Kafka, SNS, HTTP, etc. Right. Binary and structured. Binary says the protocol's probably got some mechanism for handling metadata. Use that mechanism. Structured says just shove it all in the payload. We'll show an example in a second. And we support a range of bindings. Okay. If your binding's not there, they are pretty good at taking contributions from the community, and some bindings have been defined kind of outside the community. So a binary one for Kafka, for example, would look like this. Kafka in, I can't remember which version it came in, but Kafka now supports basically headers and messages. So those things, the CE underscore are CloudEvents attributes. And that protocol has been defined, so effectively if you use CloudEvents with Kafka, then you can read the CloudEvents attributes out basically of Kafka. Structured, and all protocols have to support both, says just whack it in the body of the message in a kind of envelope fashion. Makes sense? So you can see the difference. One goes in the actual headers that the protocol supports. The other just says dump it all in the payload. Use a kind of envelope model, wrap my actual payload with this information. Okay. You need to be aware of what you're reading, obviously, because that's how you interpret it. Okay. You probably then, once you've created all these event schemas for your payload, need to do something with them. You could leave them in AsyncAPI, but one of the things that you want to think about is forwards and backwards compatibility of your schemas. So a number of tools exist out there. This is a slide from Confluent Schema Registry. I think there's one from Apicurio. I think there are a few others. And the CloudEvents team are working on a specification that let you register the schema of the message that you produce, and consumers can register their interest in it, such that you can determine whether or not your message is forwards or backwards compatible. Changes to messages are one of the big problems we get out there in terms of breaking systems. As we said, if you're a tolerant reader, you can effectively cope with certain changes, so you can be forwards and backwards compatible. Okay. So you'll probably want to dig out a registry of some sort as your estate grows bigger and register your messages and check compatibility. I would check out Confluent Scheme Registry. You might also want to go and look at something like Apicurio. OpenTelemetry. So we mentioned that with something like AsyncAPI, what I can do is I can essentially say, here is a static view of how messages are going to flow through my system. I can look at those, all those producer and consumer endpoints I've defined, and I can graph them, and I can kind of see what the flow is. OpenTelemetry would let you investigate that at runtime as well. So the way OpenTelemetry works is this idea of a trace that has spans. And a span really says, hey, I'm starting some lifetime of communication, and it can have subspans which represent, hey, I'm a worker thing that lives inside that span. So here, for example, if I was going to send a message between restaurant management, restaurant availability, I might have an overall span that begins when I send the message from restaurant management. And I serialize the span context into the headers of my message. CloudEvents doesn't define whether you're using OpenTelemetry, etc., but it has optional attributes that allows them, so you can define that in yourself. And I create another span in the child, which says I'm now effectively in the child and I'm doing work here. Spans consist of an operation name, start and finish timestamps, the context, the span ID and the trace ID, and the attributes that basically are defined, that are standard and the ones you define yourself, so that you can particularly determine what the flow is. You can see yourself flowing through these spans. OpenTelemetry has a collector, and the collector effectively you send messages to from your application, or you rely on the framework or library you're using being built around OpenTelemetry and doing it for you. And then you can effectively go from that collector to standard tracing tools. Okay. I'm not going to go into huge detail just because of time. Alex, I noticed, is running a session on OpenTelemetry later on today in room 3. So if you're interested in OpenTelemetry and want to know more about that, I would go and see Alex's session. Okay. All right, so I've built my endpoints. I've recognized their contracts. I've documented the endpoint with AsyncAPI. I have used CloudEvents to make sure that my metadata is consistent, and I can basically then have a binding between that and various protocols, both between AsyncAPI and CloudEvents in my messages. And I've registered all my events in a Schema registry. Okay, great. What other things might help me from that toolkit that I've got? AsyncAPI is pretty interesting. And its real sweet spot for me is its parser and generator model. So what happens is I've got my specification, and there's a parser written in JavaScript that will essentially parse that YAML or JSON and turn it into a model. And then what I can do with what's called the generator is I can essentially pass that model to a template. They support both React or Nunjucks. And I can use that template to generate new artifacts. I'll do that. Okay. So this is basically a React template. And here you can see the idea that what we're saying is, okay, well, why don't you have a look and see whether or not I'm publishing something. In other words, it actually means I'm subscribing, and I've got a binding of Kafka. So in other words, I've got a protocol binding of Kafka effectively on my channel. If I have, generate a new file with the relevant Kafka information. What could I do with that? Well, one of the things we've begun to do with it is say, I'll take the AsyncAPI definition. I'll use the binding information. We use SNS and Kafka. I'll take that binding information out, put it in a JSON file, and then I'll use Pulumi to generate that infrastructure that's required for that process. I will declare my queues, I'll declare my topics, I will subscribe my queues to my topics for SNS, right? So my team just declaratively says, what infrastructure do I want? Drop that in their repo, we pick it up, and we build the infrastructure for them such that we know that infrastructure is going to be available when they run their app. You can do documentation the same way. Yeah, and infrastructure as code. The other thing you can do is scaffolding. Right. Someone writes basically a definition where they say, I'm going to consume these messages. If you use a standard framework internally for consuming those messages, you can probably boilerplate a lot of an application that would need to be able to read messages from that stream. So we're certainly looking at doing boilerplate .NET solutions that effectively just say, write your handler code here. We'll do all the hard work of creating the boilerplate that connects up to that given channel, pulls messages off it and dumps it to a handler using frameworks. All you really want to write is your domain logic. Makes it very easy. All right. And I finished at that point. We have 5 minutes. So we're live. We can do questions. Wow. Does anybody have any questions? I realize you're all Norwegians and you don't actually ask questions. Hello, I've got a question at the front.
The AsyncAPI, does it have like a specification for like authentication requirements?
Okay, that's a good question. So the question was, does AsyncAPI have specification for authorization requirements? Yeah, there's a security section on AsyncAPI which lets you say, how are we going to authorize this one? And then there's basically protocol-specific information quite often on the binding which says, okay, what's going on here? Other questions? I can see people, which is quite a revolution. No? No one's going to think? All right, so I'm iCooper on Twitter. My DMs are always open. I'm happy to talk about this stuff and what we're doing with it. For us, it's definitely, we have 2,000 odd developers and hundreds of services. Become critical to us that we take control of that event infrastructure because it's become too difficult for people to discover events and too difficult for us to manage that event estate, to manage the infrastructure. We had services declaring their own infrastructure, things died. Who knew how you recovered it, right? As a production incident, somebody accidentally deletes a queue, a topic in SNS, right? And the queues all then die. How do you know how to effectively recreate that topic and who subscribes to it, to recreate all the subscriptions, right? That was a real problem for us. So this is a solution to those problems. So at a sufficient scale, this all becomes really difficult. So it's kind of this, and it's an emerging area. There's lots of emerging standards people are working on to try and make life better as people move towards events again. Feel free to ping me about this. Okay. But otherwise, if you've got no more questions, I can see. Oh, there's a question in the front.
Yeah. What is the tooling available in the .NET world? Like for OpenAPI and source code?
What's tooling like in the .NET world? So for AsyncAPI, the tooling is kind of irrespective of language, but you effectively have to use JavaScript to basically work with the generator pretty much. There was some people writing tooling in things like Go and .NET to try and do the same thing, but most of those efforts have not had a lot of traction, and the core team works on JavaScript. I'm a back-end person. I'm not a great JavaScript developer, but even I can make the React template stuff work. It's not like it's really... There's a whole template. You clone a GitHub template. You go and fill in the bits in your that you need to know, and then you're done. So it's just enough JavaScript that I go, oh, look, JavaScript. I'm writing JavaScript. Look at me. But I don't have to be a real expert. I know nothing about JavaScript. All right. Anyone else? Cool. But OpenTelemetry has got good .NET support, for example. CloudEvents doesn't need any support for a language, but AsyncAPI has .NET developers in the community, so it's not like we're left out in the cold, right? Like some places. All right. Cool. Thanks very much. Remember, you want to put the green ticket in the box outside. I got another talk tomorrow, by the way, Hustle and Flow, and that's about how you model event-driven architectures, how you figure out how to use events between systems. So please come to that if you're interested in events.